Hi and welcome. In this video, we are going to find the missing number problem. So let's see what is the problem statement, understand it, then we will move on to the logic building part. So now we are going to solve a very famous problem, most commonly known as the missing number problem. What happens in this is you are given an array A with n minus 1 elements having the values from 1 to n with one element missing. Your task is to find out the missing number. So the question says is that if n equals to 5, okay, we should have all the elements from 1 to 5 in the array. We should have all the elements from 1 to 5 in the array. That means we can have 2, 3, 1, 4, 5 in any order. The order is not defined, but we should have all the elements. Okay, in any order we can have, but we should have all. But it is saying that one of the element is missing. Any element can go missing. Last one, the first one, the second one, the third one, the fourth one. Any element can go missing, correct? We have to find that missing element. So in this test case, the fifth was missing, so we have to find the 5. Here 2 was missing, here 4 was missing, correct? So any element can go missing, so we have to find that missing element. So that is the problem. Okay, so input format is the first line contains t, that is the number of test cases, then n, that is the number that is 5 given to us, and n minus 1 element. So if one element is missing from n, that means n minus 1 elements are given to us. Okay, so these are the constraints. N is less than 10 to the power of 7 from 2, and array element can be less than 10 to the power of 7 also. As you can see in the input, in the first one, t value is 2, n is nothing but 4, and the elements provided to are 1, 3 and 4. So in this one, the missing element is nothing but 2, correct? N value is 7, and the array given to us are 1, 2, 5, 4, 6 and 7. In this one, the missing element is nothing but 3. Okay, so we have to find these missing elements. That is the question. So let's begin with logic building here. So let's suppose this is the array that is given to us. Okay, n value is 5 and the elements given to us are 2, 3, 1, 5. We can see that 4 is missing, so this should be the output. So how can we approach this particular problem? So what is the most basic approach can you think of? That we need that the element should be 1, 2, 3, 4 and 5. Okay, and we have, that means all these values should be present in this array. Okay, so how do we find it out? So one of the basic approaches for each value from 1 to 5, okay, match all the elements. So is 1 present? Is 1 present? Is 1 present? Yes, go to the next element. Is 2 present? Yes, go to the next element. Is 3 present? Is 3 present? No. Yes, 3 is present, so go to the next element. Is 4 present? No. Is 4 present? No. Is 4 present? No. Is 4 present? No. No, that means 4 is the one that is missing. We have only one element missing, so once we found that element, we can stop the code. So for each element from 1 to n, okay, we can match the array. We can match the given array. Okay, if the elements are not present, we will get the answer. Okay, so this is the most basic approach to solve this particular problem. Okay, let's see but what is the issue in this approach. Okay, but before that, let me just write it down in algorithm format. Let me just write this code down and then we will see what we will have to do. Okay, so what do we need for this particular one? The first one is taking the test case input. The second one is a loop that will be running for t number of times. The third one that we need is the input n. Okay, fourth one, an array containing n minus 1 number of elements. Okay, input of array, that means n minus 1 elements input. Sixth one is we need a flag variable in this particular problem. Okay, that will tell us whether the element is present or not. So we need a flag variable. Let's define it to be 0. Okay, now a loop will be running for I equal to 1 and this will go till I less than equal to n. So we have a loop that will be going from 1 to n, that is this one. Okay, now inside this we will have one more loop, that is a nested loop, that will run for our array from 0 to less than n minus 1, that is total n minus 1 elements and j plus plus. Okay, now if this I equal to ARR of j, that means the element is present inside the array. Then we can make flag equal to 1 and break the loop. Okay, if the element is present inside the array, we can make flag equal to 1 and break the loop. Now after this loop, if flag never became 1, what will happen? Think about it. After this loop, and if I check here inside the I loop only, if I check here that if flag equal to 0, that means if the flag never became 1, then what does this indicate? It is a very important point. So flag here is indicating whether the element is present or not present, correct? If the element is present, that means I equal to array of j. If the element is present, okay, we are making flag equal to 1. So flag equal to 1, flag equal to 1 indicates that the element is present inside the array. Flag equal to 1 indicates that the element is present inside the array. We can break after that. If the element is present, we will break it, break the for loop, correct? Now after the loop, after j loop, if we check if the flag element is 0, if the flag value is 0, okay, 1 indicates whether the element is present, yes, and 0 indicates if the element is not present, correct? So if the flag value never became 1 inside the j loop, that means we did not find our element. That means we did not find our element, and we can print I. We can print I. That means this element is missing. Okay, this is the use of flag variable. Flag is indicating us whether the element is present or not. If it is present, the flag value will be 1, and if it is not present, the flag value will not change and it will remain 0. So if the flag value is not changing, that means our element is not present inside the array. Okay, so this is the code. This is the whole code. Okay, and if we have to print I, then we can break our I loop also, and both the loops will be breaked and we will move out. Okay, so let's see this. Let's see this part. So we have 2, 3, 1 and 5, correct? So first I value is 1. First I value is 1. So let's start from here. So let's see now how this is working. So I value is 1. Okay, so I equal to array of 0? No. Is it 0? No. So loop will come again j plus plus. Is I equal to 3? No. So loop will again j plus plus. Is I equal to array of 2? Yes, it is. So flag value will become 1 and we will break the j loop. And when we come here, the flag value remains 0. The flag value remains 0, so we do nothing and we come back. Now when we come back, we have to again initialize flag to 0. Why do we need to again initialize flag to 0? Because for each and every j, we have to check whether the flag is 0 or 1. So it should start with 1. It should start with 0. If it becomes 1, that means it indicates we have the element. Now I equal to 2. Flag is currently 0. Okay. Now since flag is 0 now, is 2 present inside the array? Yes, it is present inside the array. Flag will change to 1. Okay, and we will break and it will check again. Was 2 present? Yes, so we will not print it. We will go back. Flag again will become 0 here. Okay, now I value will become 3. Is 3 present inside the array? Yes, so flag will become 1 and we will not print 3. Again it will become 0 here. Okay, I value will become 4. Is 4 present inside the array? No. Now you can see that flag value will not change to 1 because 4 is not present inside the array. And here when we come, flag value remains 0 and we will print our 4. We will print our 4. If we do not write this element, you can see the flag will remain 1 once it is set to 1. It will never become 0 again. Okay, so we do not want that. We do not want that. We have to make it 0 again. I hope you understood this point. So this is how this code is running. So now what is the issue in this code? There is no issue. The code is absolutely correct. The code is absolutely correct, but it is taking more number of operations to find the answer. It can be optimized. Now how do we see that part? Let's discuss this. In our code, we have a loop, for loop that is running n number of times, and we have another loop that is running n minus 1 number of times, correct? These two are the nested loops we have. Now in 1 second, okay, the approximate operations a computer can perform is 10 to the power of 8. In online coding platforms, in 1 second, approximate operations, it is not a standard, it is just approximate operations. In 1 second, it is 10 to the power of 8, and it depends on the language to language also. Okay, so we can generalize it, and we can think that in 1 second 10 to the power of 8 operations are there. Okay, now when we run a loop for 10 to the power of 8 number of times, and we print I in that, nothing else, we are printing. Okay, so this print is nothing but take a single operation, and this operation is performed 10 to the power of 8 number of times. That means we are performing 10 to the power of 8 number of operations. Okay, we are performing 10 to the power 8 operations here. Fine. So this will be 1 second, and if the time limit is 1 second, it will be accepted. Okay, now think about this. We have 4 that is running for n number of times, and we have inside this we have another for loop. Fine. So this will be running for 10 to the power of 7 number of times as per the constraints of our question, and n minus 1 nothing but around 10 to the power of 7 number of times. So this loop is running for 10 to the power of 7 number of times, outer loop, and inner loop is also running for 10 to the power of 7 number of times. So total becomes 10 to the power of 14 number of times. Correct? Here it was 10 to the power of 8 and 1 operation. So 8 into 1 becomes 8, 10 to the power of 8. Now 10 to the power of 7 multiplied by 10 to the power of 7 will become 10 to the power of 14. Now if the time limit is 1 second, it will not be accepted and it will give time limit exceed error. Okay, so now time limit exceed error will come. Fine, this is not a standard. I am telling you this is not a standard, but we can use it. Okay, this is generalized. Okay, so we can use it. Fine, so we can use it to get an approximate idea of how many operations we can perform in our code. Fine, just an approximation, not standard and nothing, but just an approximation. So using that, we approximated that our current program will take 10 to the power of 14 operations. Okay, and the time limit given to us is just 1 second, so it will not be accepted. Fine, so now we have to think of an optimized approach. Okay, this was the basic approach. Now we have to think of an optimized approach. Fine, so let's now begin with the optimized approach solution. Now let's begin with the optimized approach. So let's see here. So this is the elements that should be present, and this is that is given to us, and we cannot use any sorting function that is written in the question. We do not have to use them. Okay, if that was allowed, then it was a very simple problem. Now here let's see this one 2 3 1 5. What we can do now, we have to use the fact that we have all the numbers from 1 to n. We have to use this fact that we should have all the numbers from 1 to n. Okay, if we have all the numbers from 1 to n, so what should be the sum of all these values? So it is 1 plus 2 plus 3 plus 4 plus 5. That is nothing but 15. Okay, what is this? This is nothing but summation of the first 10 natural numbers. Okay, so if n value is 10, what is the summation of the first 10 natural numbers? It is nothing but the values. So what is the summation of the first 5 natural numbers? That is nothing but 15. Okay, now what is the sum of the numbers that is given to us? It is nothing but 2 plus 3 8 9 and 2 plus 3 sorry 5 6 and 11. Okay, now what is the difference between these two numbers? The difference between these two numbers is nothing but the number that is missing, that is 15 minus 11 equals to 4. The difference is nothing but the number that is missing. For example, if we have 4 5 3 2 3, okay, and we should have 1 2 3 4 5, that is the sum should be 15. So 4 plus 5 is 9, 9 plus 2 is 11, 11 plus 3 is 14. So what is the difference between these two numbers? It is nothing but 1. That is the number that is missing. Okay, its total should be 15. Okay, to have all the first n natural numbers value, but it is 14. That means 1 is missing. That means 1 is missing. Okay, so what is the approach now? The approach is very simple. The approach came out that we have n natural numbers, so total is nothing but n into n plus 1 by 2. Okay, and then we can have a sum variable that sums all the elements of the array. Okay, so that means total minus sum should be my answer. Total minus sum should be my answer. Okay, so let's now see these points, that this is the direct way. Total equals to n into n plus 1 by 2, and total minus sum should be my answer. Okay, so now we can code it. Now this is the direct coding part. The implementation here is very simple. So it's nothing but to first take all the inputs, and when taking all the inputs, just calculate the total, that is n into n plus 1 by 2. Then run a loop to calculate the sum. Okay, it will sum all the array elements, and finally print total minus sum. Okay, now this should be accepted. But let's see if it will be accepted or not, or are we missing some point. So let's implement that. So int t, okay, c in t, then taking the inputs, then while t minus minus. After this, take the input n, int n. Okay, the array c in n, and the array will be int arr of n minus 1. That is, one element is missing. Now for int I equal to 0, I less than n minus 1, I plus plus, that means total n minus 1 elements, c in arr of I. Fine. After this, total equals to n multiplied by n plus 1 divided by 2. N multiplied by n plus 1 divided by 2. Okay. After this, let's calculate our sum also. Int sum equals to 0. So for int I equal to 0, I less than n minus 1, I plus plus, take all the sum as the elements, sum plus equal to arr of I. Okay, what is here? I. Fine. So we have sum, we have our total, we just have to print total minus sum. So total minus sum. Okay, and a new line for multiple test cases. Fine. Let's just run it out. So Once we run it, we will see whether our code is working correctly or not for the test cases that we are seeing. And when we submit it, after that we will submit and see whether it will be accepted or not. Fine. So let's take some test cases. Let's take 4 test cases, or let's take 5 test cases. Okay. The length is 5 and the elements given are 1, 2, 3 and 4. That is the last element that is missing. So it says that 5 is missing, so it is working perfectly fine right till now. Let's take another 5. Now first element is missing. So yes, it is working for the last element, for the first element. Now check for the random elements. Second element missing, yes. 1, 2, 3. Second last element missing, yes. 1, 2. The middle element is missing. 4, 5, yes. So yes, it is working for all these such cases: last element, first element, middle element. Okay, so let's now copy it and submit it and see if it is correct or not. So I copy pasted the code and it is submitting right now. Let's see what it says. It is correct, not correct, will it give me TLE or not, or some kind of other errors. Let's see that. Okay, so it gives me a wrong answer. It gives me a wrong answer. Okay, fine. Okay, so let's see the hint here. Check if you're taking n elements. Yes, we are. See the constraints and think what can be the final values in different cases. Handle cases for all the values. Okay, so we have taken the first and the last element values. Okay, so check for the boundary conditions. Fine. Okay, let's see these. So n2 less than equal to n less than 10 to the power of 7. 2 less than equal to n less than 10 to the power of 7. Okay, so we are taking, let's take n value as 10 to the power of 5. Fine. Let's take n value as 10 to the power of 5, and in our code, let's see what will happen. Let's see what will happen in the code. So I will be just doing this part now to explain you. Let's see. I have commented that, and let's see our total value. In total, okay, int n, c in n. Fine. Now in total equals to n into n plus 1 by 2. Okay, so I'm just checking whether this value is correctly calculating or not. Okay, now see our total, new line. Okay, let's just do this inside a while loop that is running for t number of times. Okay, so we can check for many inputs simultaneously. Fine. Now let's run the code and see whether we'll get a correct answer or not for multiple test cases. Fine. We cannot have a 10 to the power of 7 test case. So let's check for each and every line whether this is correct or not. So let's test for 10 So if it is 15, so the answer is 120. So let's see here, 15 multiplied by 16 divided by 2. So the answer is nothing but 120, and it should come as 120. Okay. After this, check for 100. The answer is 5050. So 100 multiplied by 101 divided by 2. The answer is 5050. Okay. Check for 1000. The answer is 500500. I think it will be correct. 1000 multiplied by 1001 divided by 2. Answer comes out to be 500500. Just increase to 10 to the power of 4. Let's go to 5. And answer comes out to be 7050870. Let's check this. So it is 1 2 3 4 5 multiplied by 1 2 3 divided by 2. So the answer here comes out to be 500500, but here the answer is something else. Okay, so this is the issue here. There is an issue here. The answer is this. Okay, that is 1 2 3 4 5 6 7 8. The answer is this, but the answer comes out to be something else. So what is the problem? What is the issue here? The issue here is the range of integer. Okay, when we multiply n into n, and the value is 10 to the power of 5. Okay, or around that, 10 to the power of 5 multiplied by 10 to the power of 5 should be how much? 10 to the power of 10. Okay, if I just show you that point, n into n, what should be the answer for n into n? It is nothing but 10 to the power of 10. Okay, so it should print 10 to the power of 10. We are again dividing it into more subparts just to check. In total, n into n plus 1 is coming out, correct? So we are checking that part now. So n value during 10 to the power of 10, is it coming correctly or not? Okay, let's check that part. So 1 2 3 4 5. Okay, so it is 1 2 3 4, it is coming correct. So 1 2 3 4 5. Okay, here it is coming wrong because it should be 10 to the power of 10, but it is not. Now let's think. Integer in competitive programming have 32 byte, so 2 to the power of 31. Till 2 to the power of 31 sign integer, correct? 10 to the power of 10 is outside that range. 10 to the power of 10 is outside that range. That means we need to change something. Okay, that means we need to change something. So we need to change the data type. We need to change the data type to long. Now if we take long n, okay, and just do it here, that is 10 to the power of 10, the answer should come as now 10 to the power of 10 because we have taken now long, correct? So 1, 1, 2, 3, 4, 5. So now the answer comes correct. So that means we have to change our data type. Fine. So we have to change our data types. That is the crux that we got. So int value will be long. Okay. Now if I just do 10 to just I gave 10 to the power of 5 as the answer, total value should come as 5000, 500, something like that. Correct. So 5000, 5000. Okay. So let's see. 1, 2, 3, 4, 5. So now it is coming at 5000, 5000, and n to n is nothing but 10 to the power of 10. Okay. So we can use this approach. We can use this approach inside our own code. I mean, can't we? So inside the code that we have written, just uncomment that code now. I'm just uncommenting that code. So here we can just do this. Fine, and change the data types. So we can have long, okay, integer n minus 1, but n is long. So here also long, and sum also long. So now it should give the answers correctly. Okay, now it should give correctly. One more way is keep it int, because this one array range can go till only the integer part. So just keep it int, and we can substitute, we can typecast it here. Now we are telling that n typecast it to long. Okay, that is the same thing. Because integer is faster than long, then we are not converting whole the code into long, but only the required part. So we converted the required part into long because we have converted the typecasted n into long. Fine. So now just copy paste the code, just this part of the code, and test it out whether now it is correct or not, because first we were not handling the integer overflow, but now we are handling the integer overflow. So let's now see this. So once I copy paste and submit it, now we have long range. So range is overflowing is handled till now. Okay, so in long we can go till around 10 to the power of 18 inside long. So now it is accepted. So let me just show you some experimentation here. So if I change it to this part, that is, if I change about, now will it work? No, it will not work. The reason being n into n is still integer into integer. Okay, and the answer should be of long. So we have to change it inside. The damage is inside, so we have to change it inside. At least one should be of the type long, so that it should have the capacity to store 10 to the power of 10. Okay, so this was the code for this particular problem. Okay, we have to take care of the time complexity, and we have to take care of this integer overflow. Okay, and use the long data type for such particular problems. Fine. Thank you.